Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. We'll go ahead and finish up section 2.2 with quadratic functions here today, and a couple of these will be a little bit more challenging, especially the first two examples that we look at. So, the first example that we're going to look at is writing an equation in vertex form where we have f of x equals negative 1/3 x squared plus 3x minus 6. Now, there are two issues that are going to show up here that certainly, aren't ideal. We'll talk about how do you work with it when a is a fraction and when b is odd. I mean, that's something we haven't gone over yet, but we do want to make sure you at least know how to work with that situation. So, first thing we'll do is, kind of as always, move the c term over just to get it out of the way. And then we will go ahead and factor a out. Now, when you factor a fraction out of a number, certainly if you want to see this, if I take 3 divided by negative 1/3, I end up with negative 9. All right, so again, I am going to, kind of as always, leave that space. Now, the one thing that, like I said, does make this a little bit ugly is when we take half of 9, I'm going to leave it as a fraction. So, when I take 9/2 squared, that's going to be 81/4. Now, the other thing that I'm going to do, just kind of off to the side here, is if you take 81/4 times negative 1/3, well, let's see here. That's going to reduce. So we end up with negative 27/4 when we balance it. So, from here, we have negative 1/3 x minus. Well, if you haven't noticed this yet, when you complete the square, basically whatever, what multiplies to 81/4 adds to negative 9, it's whatever number you squared. So this is just going to be minus 9/2. And then if this is minus, that's a minus. So, then on this side, again, just kind of have 6 minus 27/4. Again, if we make that a 1, so that gives us f of x, so that's 24/4 minus 27/4, so minus 3/4. And then the final thing that we do is add that over. So, again, not the easiest example where when you have a as a fraction, b is odd, but those are two things that we do at least want to make sure you've seen at some point, because unfortunately, not everything works out nice, neat as clean integer values all the time. All right, example 2. Now what we're going to do is we're going to use the general quadratic form and go over how to write that in vertex form. So, and certainly, even though I know it wasn't asked, the vertex of this parabola, 9/2, 3/4. A is negative 1/3, meaning it would open down, has a vertical shrink as well, just to even talk about a couple of other topics too. All right, so write in vertex form ax squared plus bx plus c. Well, again, first thing, move the c over and factor a out. Now, one of the reasons why, if nothing else, kind of went over this one is just to show you some maybe more unorthodox factorings. Well, if I factor a out of b, or divide a out, you're left with b over a. If nothing else, think about it as if you were to distribute things back through. A times x squared, ax squared. If I multiply a times b over a, the a's are going to cancel, leaving me b. All right, so again, sometimes I do like to kind of have certainly my work off to the side. So we take half of this. Well, basically what that means is it's, if you divide by 2, it's like multiplying by a half. So I'll even write in the 1 if it helps to see that. And so when I do that, well, that's just b squared over 4a squared. So again, writing this into vertex form, I'm going to add b squared over 4a squared. Now, this even kind of allows us to go back, talk about what I was just saying. You know, in terms of you multiply a with b over a, the a's cancel, it leaves you with just the b. Well, here, if I multiply a over 1 to balance this by b squared over 4a squared, well, what's going to end up happening? One of the a's cancels on the top, one of the a's on the bottom. So I am going to be adding b squared over 4a to that side to balance. All right, so the next thing that we are going to do is factoring on the right side. So again, x, again, what multiplies to b squared over 4a squared and adds to b over a? Well, it's going to be plus b over 2a, which again, as I mentioned, whatever you square is what ends up there. And so from here, now what we are going to have to do is I have a minus c over 1 plus b squared over 4a. Well, again, in order to balance, to get a common denominator, got to multiply by 4a, so I end up with, and I'm just going to rewrite this with the positive term first, b squared minus 4ac over 4a. And then our final step is to move this back over. And what you're going to see is eventually what we have ended up essentially building here as we do this. Again, when you know, if you look at some of what we have here, well, b squared minus 4ac, that's up here. This is the discriminant of your quadratic formula. Now, some of the other things, you know, again, think about this. What would be the actual vertex? Well, the actual vertex, h, opposite of b over 2a, which I actually have the notes from yesterday right here. H equals opposite of b over 2a. So the basically, again, as you do this, we are coming up with what would have been quadratic formula. So again, I know it's not exact. You know, you do have the, you know, the 4a here, because if you were to actually end up solving this, you would take the square root over on the other side. But again, basically, the quadratic formula comes from if you complete the square of vertex form without any coefficients. So, one final example. Path of a baseball in feet is f of x equals negative 0.0032 x squared plus x plus 3. What is the maximum height reached by the ball? Well, if you think about it, let's say we have baseball player here. He hits the ball. It is going to go up for a while and then eventually come down out here, hit the ground. Well, what's the maximum height reached by the ball? Well, again, basically what they're asking you for is the vertex. Now, you have a couple of options here. I suppose if you really wanted, you could complete the square. I would not want to deal with completing the square when a is negative 0.0032. Here, I'm going to say use that formula we derived yesterday. H equals opposite of b over 2a. Well, here, opposite of b, negative 1, 2 times a, negative 0.0032. And so, when we do that, negative 1 divided by 2 times negative 0.0032. So, 156.25 feet. Now, here's where you have to be careful. That is how far away from the batter horizontally the ball reaches the maximum height. The maximum height, so remember h is x. K is our y value. So from here, we'll plug this back in for x. And when we do that, we end up with 81.125 feet. So, again, around 81 feet. As certainly as you guys are working on homework on Pearson, they'll tell you how exact they'd want you to round. But I'll just, since that decimal is not too big, I'll just leave it like that. So, other than that, that finishes section 2.2.